You know that feeling when you're coding and you realize you've just copied and pasted the same chunk of code for the third time? Yeah, we've all been there. Today, we're going to talk about the solution to that exact problem, Python's inheritance. It's a seriously powerful tool for making your code cleaner, way more reusable, and just more logical by letting your objects share their smarts.
All right, so here's the game plan. First up, we'll cover the golden rule of programming that makes all of this necessary. Then, we're going to jump into the basics of inheritance, your first real tool. After that, we'll see how to tweak and customize things, then get into the wild world of multiple inheritance, the good, the bad, and the ugly. And we'll wrap it all up with a really cool, very Python way of thinking called polymorphism.
Okay, let's kick things off. Before we even get into the how, we need to talk about the why. Why is inheritance such a big deal? Well, it all comes down to one core idea.
And this really says it all. This brings us to the golden rule, DRY, which stands for don't repeat yourself. Just think about it. If you have the same code in 10 different spots and you find a bug, you now have to go fix it in 10 different spots. You're almost guaranteed to miss one. It's an absolute nightmare to maintain, and this is exactly what we want to stop from ever happening.
So, what's the answer? You guessed it, inheritance. It's this awesome idea where we can create a general parent class that has all the common stuff and then make more specific child classes that just, well, they inherit all that goodness. The key thing to remember is this is a relationship. Like a poodle is a dog. A supplier class is a contact class. It's that simple.
All right, enough theory. Let's see this thing in action. We're going to start with our first tool, basic inheritance.
Okay, so take a look at this. We've got a super simple base class here, also called a superclass, named contact. When we create a new contact, its init method does two things. It stores a name and an email, and then, this is important, it adds itself to this shared list called all contacts. Nice and easy, right?
Okay, now what if some of these contacts are also suppliers? Well, instead of copying and pasting all that code, we can just tell Python, hey, a supplier is a type of contact. And we do that just by putting contact in the parentheses right there. Boom, just like that, the supplier class gets all the powers of the contact class.
And here's where the magic really happens. When we create a supplier, it automatically gets a name and an email. It automatically gets added to that all contacts list. We got all of that for free. But we also gave it its own special power, this new order method that only suppliers have. And the best part? The original contact class is totally untouched. It's clean, it's simple, love it.
Okay, that's perfect for adding new stuff. But what if the child class needs to do something a little differently than the parent? That's where extending and overriding behavior comes into play.
So let's create a new class friend, which is also a contact. But for friends, we want to add a phone number. Now, the first thing you might think to do is just write a whole new init method, right? Like you see here. But whoa, hold on, look closely. We're repeating code, setting the name and email again. But worse, much worse, we've introduced a nasty bug. That line that adds the contact to our list, it's gone. We've completely broken the functionality we were supposed to inherit.
So how do we fix this? The answer is one of the most important tools in inheritance, the super function. Think of super as a direct line to the parent class. In this corrected code, when we call super.init, we're basically saying, hey, contact class, do your init thing first. So it sets the name, sets the email, adds to the list, and then, once all that is done, we come back to our friend class and add the new phone attribute. It's perfect. No repeated code, and more importantly, no bugs.
Okay, so far so good. Everything has had just one parent. But what if an object needs to be two different things at once? This is where we pull out the big guns, a feature called multiple inheritance.
Now, one of the most common and frankly safest ways to do this is with something called a mixin. A mixin is basically a little class that just gives you one specific superpower, like the ability to send emails. You never use it by itself. Instead, you mix it in with another class. So here, we've made an emailable contact that gets its contact info from contact and its email powers from mail sender. It's the best of both worlds.
But this is where things can get a little dicey. It's easy when the parents give you different abilities. But what happens if both parents have a method with the exact same name, like underscore underscore init, underscore underscore? Which one wins? How do you make sure they both get called? This little problem has a famous name.
It's called the diamond problem, and you can see exactly why from this diagram. You've got your subclass at the bottom. It inherits from two parents, left subclass and right subclass. But uh-oh, both of them inherit from the same grandparent, base class. Now, can you see the issue? If your subclass calls both its parents, it might accidentally call the base class method twice, and that can lead to some really weird bugs.
And guess who comes to the rescue again? Our old friend super. If you look at the naive approach on the left, where you call each parent by name, that's what causes the double call bug. But the super approach on the right, it's so much smarter. It doesn't just look at the direct parents, it looks at the entire family tree and figures out a path to call everyone exactly once.
So how does it do that? It's not magic. It's something called the Method Resolution Order, or MRO. Before your code even starts, Python looks at the diamond and calculates the single best path to visit every single class. It's like a pre-planned route. So when super is called from left subclass, it doesn't just jump up the base class. It knows, nope, my next stop on the MRO tour is right subclass. Then right subclass gets its turn, and then it calls base class. It's this brilliant little system that guarantees everyone gets called, but only once.
Okay, so inheritance is awesome. But sometimes it can be a little too strict, a little too formal. So now let's switch gears and look at a different way of thinking that is super flexible and very, very Pythonic.
That big idea is called polymorphism. I know it's a fancy word, but the concept is super simple. It just means you can have a bunch of different objects and you can ask them all to do the same thing, and they each know how to do it their own special way. Think of a media player. It can just call .play on a file. It doesn't care if it's an MP3 or a WAV file. The file object itself knows how to handle the play command.
And Python takes this idea and runs with it, with a philosophy called duck typing. It's based on this classic saying. In the world of Python, we don't really care about an object's official family tree. We just care about what it can do.
Look at the difference here. Classical polymorphism says an object is a certain type. It must be a subclass of audio file. But Python's duck typing? It just asks what the object does. Does it have a .play method? Cool, then I can play it. It doesn't need to inherit from anything. This makes your code so much more flexible because you're focused on behavior, not some strict family tree.
And this isn't just theory. This is how huge real-world apps are built. Check out this real estate application. You might have something like an apartment purchase that inherits its location and size from a property class, but it also inherits its sales logic from a purchasable mixin. You're combining the is-a logic of inheritance with the can-it-do-this logic of duck typing. That's what lets you build really complex but still manageable systems.
All right, let's bring it all home. What are the big takeaways? First, use inheritance to keep your code dry. Don't repeat yourself. Second, super is your best friend for safely extending or changing methods you've inherited. Third, multiple inheritance is powerful, but you got to be careful and always use super to avoid those diamond problems. And finally, don't forget that in Python, sometimes the best approach is to stop worrying about what an object is and just focus on what it does with duck typing. So I'll leave you with this one final thought. Take a look at some of your own code, some project you've worked on. Are there places where you've built these really strict, rigid family trees for your classes? And now, knowing what you know, could you simplify it all just by asking, does it quack like a duck? Because focusing on behavior over type, well, that can totally change the way you think about and write your code.